Hello everyone, my name is Eugen Wintersberger and I'm the Director of Engineering at the HDF Group. Thank you so much for joining our first HDF Group webinar. It's my great pleasure to announce the HDF Group webinar series. We hope that now it's not working. I cannot move my slides. Some technical difficulty.
I will take over there.
Okay, so I hope we'll provide a platform to bring the members of HDF5 community together to share information about the projects that are going in the community and to share best practices of developing software based on HDF5. So we hope that we can learn from each other, generate new ideas, and find new collaborators and friends. Some backgrounds on today's presentations. It was almost a year ago in March 2018 when a few members of HDF5 community, now long-term collaborators and C++ enthusiasts, got together to form HDF5 C Group. And we wanted to find the answers to the questions, how should contemporary C++ interface to HDF5 look like? Can we come with interfaces that will work for everyone? So we started with sharing the projects we have been working on. We discussed our vision of HDF5 C++ interfaces, best practices, new standards, and learned from each other, suggested improvements for HDF5, and of course we argued with each other a lot. So we had really great fun, only to conclude at some point that there's probably no interface that will fit all. And we decided it would be very appropriate to share the HDF5 C++ projects we have been working on and our experience with the wider community and bring other members to the discussion. And as a result, we decided to have this webinar that, to our surprise, generated such a tremendous interest. Today we will listen to 3 presentations on the HDF5 C++ libraries that are developed and supported by the members of the HDF5 communities. You can see the links to repositories and to the project descriptions on the slide, and you will have those links in the email that was sent to forum. You probably noticed that first 2 presentations in the spirit of HDF5 have self-describing and unique names, and believe me, we spent some time arguing about this issue too. Steven's name is very familiar to the forum members. Marc and Eugen represent Light Source community. Light Source community adopted the very first version of HDF more than 20 years ago, and we have long-term collaboration history with this community. And the HDF Group collaborated with Chris and Marc to promote HDF5-based solutions to the high-energy physics community. So before we start, there are some general guidelines for asking questions. You will see in your webinar window questions section. Please type your questions there and indicate who is this question for. Questions will be addressed at the end of all 3 presentations. We do not want to interrupt presenters. And then each presenter will have time to answer just few questions, and they probably will be able to answer as the seminar goes, but also they will pick up few questions at the end of the seminar and answer them. And then the questions that will not be answered, we will ask our presenters to write answers to all other questions, and we'll post them on forum. So don't worry, all questions will be answered and posted. This session will be recorded, and we will be sending the link to the recording and to the question and answers document as soon as they're available. As I mentioned, you have links to presenters' projects, and here's another link, and you can find it on forum if you look on the news and announcement sections. And feel free to reach out to them because you know who they are. They really welcome conversations. And if you are interested in continue conversations on HDF forum, you may join C++ users group. You will see the section in the forum. On another note, if you are interested in presenting this seminar, you can contact me at the informalhdfgroup.org. And next seminar will be on Tuesday, February 12th at 10 a.m. Central Time. And it will be presented by a company called MyEra Research Reproducibility, a firm that uses HDF5 to carry the mission to make reproducible research a reality by making it cheaper, faster, and easier than using conventional non-reproducible methods. Sounds very exciting. So before we start, I really would like to thank my colleagues Gerd Heber, who came up with the original idea of getting the HDF5 C++ community enthusiasts together, and Lori Cooper, from whom you received multiple emails on this seminar, who put a lot of energy and planning in preparation of this event, and who really kept us well organized. And now I'm passing to presenter to Gerd, and then Steven Varga to present the project called H5 CPP Capital.
Thanks, Elena. Yes. Hi, my name is Gerd Heber, and I'm just here as a warm-up act for Steven, who will take over this presentation at some point, but here it is. And for some of you who might be just on the phone, if you go to that URL, webinar.h5cpp.org, you can follow this in a browser, so you don't have to use the GoToMeeting client. Okay, we'll talk about H5CPP, and that means we have to compare ourselves against sort of the gold standards, what I would call it in the field, as far as performance is concerned, and you can read that as the C API. And as far as usability goes, you can, H5Py, I think, is a perfect example that shows that HDF can be dealt with in a very usable fashion. And you are certainly entitled to ask, well, what's in it for me? What does H5CPP capitals give me? And we'll talk about that in the course of this presentation. And then finally, we'll leave you with some pointers to resources, how you can install it yourself. Now, usability. So here is actually the example that Andrew Collette gives in his book, Python and HDF5 in chapter 1. And what he does is the code is very self-explanatory. We are creating two variables, we store them, we decorate one of them with an attribute, then you have sort of the NumPy style slicing and dicing. You can take that then to creating data sets with more customized properties. You can do single point assignments and enable compression and things like that. So I think this is a pretty good benchmark, albeit a micro benchmark for usability. If you implement that in H5CPP as it stands today, I would suggest that H5CPP is actually pretty close to that. There isn't quite as much syntactic sugar as in Python, but that could be added, but it's pretty close. The line count, you can pretty much go through it line by line and see the resemblance. C, on the other hand, I would suggest is not even close. I didn't bother writing this out in C, but you would need about 20 different API calls to make that happen, and so you wouldn't see the forest for the trees, what the simple program actually does. Now, in implementing H5CPP, Stephen has conveyed to me sort of several what I would call values. Our expectations are that it's certainly something that's very idiomatic, and by idiomatic mean in line with idioms common in modern C++, starting with C++11. Likewise, it's very difficult for anybody to keep all the different API calls in their head, so the fewer the better. And in the case of H5CPP, there are basically 4 basic templates, and that's all you have to remember. So I would suggest this is like in a RESTful interface world, sort of the CRUD style, the create, read, update, delete idea. It's also for productivity crucial that people out there, they use, for example, linear algebra systems such as Armadillo and Blitz and Eigen and so forth. And you want to be a team player here. It's not a good idea to tell people, oh, you can have only standard C++ vectors. That's typically not a good starter. Performance certainly is crucial, and our goal is clearly zero overhead over the C API. And then as far as productivity goes, it's very desirable to get started even if you don't have any previous knowledge of HDF5, so zero knowledge is the goal. And then, yeah, no boilerplate, so you don't want to bother with people asking them to sort of write a lot of compound type creation and those types of things. Now, here are a few additional heuristics, and that's where different C++ frameworks start to deviate, is Stephen considers H5CPP in relationship to the C language. Definitely C is part of the family, so this is not a completely different language. So we believe that there's very little reason to re-implement or repeat the C API in any form. And however, if you desire to take total control of certain aspects of the C API, nothing prevents you from doing that. And obviously, in many different respects, users like choice. So if it's conceivable that people have good reasons to choose differently, then by all means, we would like to support that. And we'll see examples of that in a moment. And obviously, as in sort of good old C++ tradition is, you don't pay for what you don't use. In other words, for example, we think that runtime polymorphism is not a good idea here. And then we want the compiler to work hard for you rather than you working hard for the compiler. So at compile time, you want to do things like copy elision and so forth. Now, the question is, in what form does H5CPP come? And it comes in two parts. There is a header-only template library part that you can download as one installer. And then there is a second component, a source-to-source compiler based on LLVM. But you have the option, there's no obligation to use them together. If one does the job for you, by all means, just use one. But this presentation might give you some ideas that two might be very useful as well. What does it do? We saw some highlights already. So this is a very familiar idiom in modern C++, the RAII, meaning that resource management goes through the life cycle of objects. And so the constructor acquires resources, destructors release resources, CRUD-like operators to really keep it to a minimum of read, write, create, append, and that's about it. And we talked about interoperability with the C API. And again, this is a field where people make rightfully different choices. It can be in the simplest case, and that's the default, perfectly seamless. So any descriptors that you create on the C++ side will automatically be converted to the corresponding C APIs as HIDTs. But then if you want to exercise more control, so you want to prevent your users from either from C++ to C or the other way around, there are preprocessor definitions in H5CPP that give you sort of explicit control over that. Error handling over structured exceptions, integration with third-party libraries. One of the more popular APIs in the HDF5 C API in the high-level, in double quotes, API is the packet table. However, it's known that that's not a great performer, and it has a lot of idiosyncrasies. But in H5CPP, I think we have something much better. And there's also a high throughput I/O pipeline. Stephen will speak to that. And that's where the LLVM part sort of comes into its own, is really that, yeah, the C API invites you just to write all this non-problem oriented code that just deals with plumbing, with opening and closing handles and things like that. So the compiler should take care of that. And if you are just coming from the C++ side, H5CPP offers you a rather non-intrusive way to persist to serialize C++ object in a very sort of platform-neutral way. And there's a lot more, but I'll leave it at that for now. Now, as far as usability goes, let's see some examples. So here's the RAII idiom in action. That file descriptor fd_t. Yeah, that is really the underlying HDF5 file is tied to the scope and lifetime of that. So that file will be automatically closed when that goes out of scope. And as far as type support goes, all the primitive types, the built-in types are supported, then plain old data structs of these types, and likewise arrays with them with the third-party libraries like Armadillo in this case, for example. And then, yeah, everybody knows that the number of HDF5 function calls is already very large, and we keep that number down through these property list arguments. Otherwise, there would be even more functions. So in H5CPP, Stephen came up with a very clever mechanism of providing these arguments. However, you can provide them in any order, so you don't have to memorize complex permutations or rules. Just provide them in any order you want, and then if they are of the same type, you can actually combine them with this nice sort of pipe or syntax. And we briefly talked about the C API policy. So the default is automatic conversion, but you can take control. So if, for example, you want to prevent your users from automatically using C++ descriptors as HIDTs in the C API, you can prevent that with a preprocessor definition that will generate a compilation error. And likewise, the other direction, if you don't want these HIDTs automatically be promoted into the appropriate C++ type. And likewise, structured exceptions. So this is a very nice way of really, in your code, should you choose to do exception handling, to express what kind of exceptions you would like to handle and in which order, in which priority, and so forth. And then there is also sort of a wildcard, the H5 error any exception class. And then finally, this is actually a complete C++ program except for the declaration of the main function. It's very clear what it does because it's short and very idiomatic. It basically has two structure definitions, and it writes an array to a data set of one of this one type, and then reads it back. However, it reads back only the first and the third field of that structure, and in different order. But this is really all the code that you need to write. You don't have to define compound types and so forth. The source-to-source compiler generates that code for you. And then you can use your favorite compiler, your favorite C++ compiler to compile and run that program. And that's the point at which I will hand it over to Stephen.
Thank you very much, Gerd. Just can you move the slides for me?
Yes.
Excellent. So one of the new feature of H5CPP is a real packet table that takes arbitrary types and changes them in the stream. It is high throughput and very efficient in implementation. And one of the interesting feature that is entirely based on the new C API chunk, direct chunk IO. Can we move for the next one, please? That can be enabled with the H5 high throughput flag. This new IO is cache-aware and blocked, much similar to matrix multiplication blocking algorithms. Is provides a possibility for parallel filter change by transferring the stream into embarrassing parallel problem and then processing them in a separate threads. Also exploring the possibility for direct MPI IO and Romeo. This feature will be different from the parallel IO framework of HDF5, current parallel HDF5, and will be header only as well. Now the following measurements were done on an average laptop, corporate laptop, with about 500 megabytes per sec IO throughput. Now, in larger blocks, in this case, a 2 gigabyte block has been written and read back. It basically gives a ballpark where H5 CPP stands respect to POSIX IO. The POSIX IO calls were done with Armadillo save and load calls, and it's pretty much in the same range with some differences in the next slide. That shows that in some way the buffering seems to be better with one single file approach, such as done in Armadillo. However, that's not the entire picture. HDF5 provides additional features through chunking, such as compression and filter chains, that is missing from the Armadillo POSIX IO calls, and hence the higher read throughput. Can we move to the next slide, please? Now you can try it, both the header-only version and now binary packaged H5 CPP toolset with static LLVM linking. This is necessary for now because of the LLVM architecture quirkiness. You can install it for standard DBM-based systems as well as RPMs provided for Red Hat package managers and Tor gzip also. Hopefully, soon enough, you will be able to see Windows MSI packages as well. This is the current standing of H5 CPP, the big picture. Most linear algebra libraries, popular linear algebra libraries are already supported, as well as fundamental types and arbitrary path types, arbitrary embedding. The STL vector is supported, and hopefully with time, the entire STL containers will be in the supported list. Thank you very much for this opportunity for the HDF Group, Alina, and Gerd Hieber for his efforts putting into this presentation and throughout the year.
Thank you, Steven. So our next presenter is Eugen Wintersberger, who will talk about H5 CPP low case wrapper.
Hi all. I hope audio is good.
Yes.
So, okay, let's go. Can you see, is this pointer is working?
Yes, it is.
Oh, that's great. So, okay, unfortunately I lost my presentation when I moved it to Windows, so the animations are gone and I have to work with PDF. Yeah, we are more or less, as you can see, we are the non-capitalized version of H5 CPP. And you will also see we have quite different approaches to the same topic, obviously. Let me give you a short overview. We will show you what were the major goals when we started this project in 2017, if I recall correctly. We'll give you a couple of examples about code examples and show a little bit how the library works. Then I will give you an overview how to use it, and finally show you a little bit how the entire project is organized and what we are doing in order to ensure that this project can live on for quite a while. So, okay, what we try to solve is one of the big things that the big problems I have with HDF5 when I started with the C API is resource management. We wanted to have more than C++, which means larger C++ 11 or larger equal. We wanted to use SDL algorithms, basically don't invent the wheel, but use what is there. I wanted to have a library which is easy to use, and that means not only a simple API, but it should be simple to install, and it should be simple to build code with. We are heading towards full functionality of the C API, though we have to still some work to do on this topic. And we wanted to solve some tricky issues which came up over the years when I used the API, but I will show you what I mean if once we're on the way. So, okay, few words about the library's design. And so, unlike what you've seen before, we are following a very, very classical C++ design. So the entire thing is distributed over a couple of namespaces. And if you have a look on these namespaces, they pretty much mimic the organization of the C API. Now, someone could say, as before, don't repeat what is already there. There are some reasons why we wanted to have this, which I can show you later, for instance. But HDF5 already has some kind of object-oriented approach just done in C. And what we try to do here is put it on the next level. So we do RAII, as pretty much everyone does today in C++. And if you have a look on the code here, for instance, at line 6, we create a file, we create a data type, and we don't have to close anything. We even get exception safety, because whenever this scope here is left, everything which has been constructed within it is released by calling its destructor. And the fundamental building blocks we're using are nodes and links. And what we are doing, our imagination of HDF5 is it's a tree. It's a unidirectional tree which consists of nodes and links. And the nodes are what, you know, as data sets and groups. The links are basically the edges between the nodes. And the links are also those guys who have a name associated with it. And by doing so, if you can see on the very right side, is every link has a path and a file, and every node is associated with a link. And this solves a really nasty problem I had with HDF5, and some of my colleagues had the same issue too. When you access an object via a path, and this is maybe not the hard link, but a soft link or even an external link, and you ask the object for its name, what you get is not the path you use to access it, but you get whatever path. If this is an object residing in an external file, you get something entirely different. And so what we're doing in our API is we keep track of where objects are coming from. So whenever you open an object and you ask it, who are you? You get the link you use to access the object. Okay, so everything, we follow here a quite, let's say, conservative approach when it comes to syntax. Objects are constructed by, well, their constructor. We have a path object, which represents an HDF5 path. It can be implicitly constructed from a string, but anyhow, well, a string is something different than a path, so we are a bit more conservative here maybe. The other thing you can see here is, let's say here we create a data space, a data set, and we provide support for virtually all basic C++ types. This includes the primitive types. We have support for standard vector and standard array. I/O is quite simple, as you can see here. Of course, we write everything. Another thing which is always a little bit of a problem, in particular, the work I did before, I had to, iterate over a lot of HDF5 files, which had a quite complex structure sometimes. And doing this can be really nasty if you use the standard HDF5 procedures. Now, every group, for instance, we have now provides two STL-compatible interfaces, nodes and links, where we can do simple iteration over direct childs. We can use recursive iteration. We can access links as well as nodes by their name or by their index. And this is basically how it looks. For instance, here, the idea is we iterate over all links attached to a group, and we want to know what's your path and what's the type of the link. And as you can see, you use just plain standard C++. Okay, there should be a standard begin and a standard end function here. This is what we have to add. The other thing here is, like here, this is an example where what we want to have is recursively iterate through all the nodes within a file, or better, all the nodes below a particular parent group, and give me all the data sets and store these data sets in a standard vector. And this is pretty much it. I mean, if you recall the C API where you have to use this visitor interface, that's definitely an improvement. We have basically the same interface for attributes. And the only thing there is, of course, no recursive iteration. For the sake of completeness, a bit of code. Attributes are created by the management interface using a create function. You can use I/O on them. As with standard HDF5 attributes, you cannot do partial I/O, of course, with these guys. But you can access them by index, you can iterate, you can access them by name. So this is quite similar maybe to what you know from H5Py or PyTables. So now let's talk a little bit. We have maybe a bit different approach how to deal with custom types. And the way how I want to explain this by means of an example. And to consider we have an image template, and which uses a pixel type as a template parameter, and then we want to store this in an HDF5 file. So the way how you would do this here is, the first thing you do is you implement, you have to provide specializations for type traits, and like this one here for the pixel type. And what this type trait does is it simply tells the library how to construct an HDF5 data type from an instance of a particular C++ type. In this case, we use a compound data type, and we call this red, green, and blue, and it's all unsigned integers. So this is, let's say, about 33. Yeah, let's say it's about 20 lines of code you have to add. The other thing you need is, if you want to do, for the image, we want to have something like a trait which constructs a data space. And the way how you do is you take, again, there is a type trait for it, and it tells the library how to create a data space from an instance of an image. In addition, it tells the system where to get, how to get access to the pointers to the memory of the particular data structure. And now, as we go, this would be, once you have provided this to classes, this is the entire code you use to create a data set and write an image to an HDF5 file. Okay, here we go. Yeah, partial I/O. Partial I/O is difficult in HDF5, and that's particularly because the mechanism itself is very powerful, but as with all powerful things, it's also very complex. The example implemented here is something you do quite often. You append data to a particular data set as you go. And we currently have an implementation of point selections and hyperslabs. What we have to do is to make it a bit more comfortable to connect them together. This would be the most simplest example where when you call the write method, you provide it with the data and you provide it with the file selection, and then you can basically write your data, move on with your selection, and repeat the cycle again. So, okay, using the library. We currently support Windows 7 and 10 using the Visual Studio Compiler Suite 2015. Or alternatively, you could use a GCC, everything larger than 4.8 will do. We support Linux, the same compiler requirements, and OS X with Apple Clang 9 and larger. The HDF5 version we recommend is 1.8.12 or larger, but of course, better use 1.10, whatever is the actual patch version. If you're on Windows, you most probably, if you're on Linux and if you're on a Debian-based distribution like Ubuntu, we can most probably provide you with already pre-built packages. Packaging is done by Daisy in this case. It's a German light source located in Hamburg. And if you're on Windows, most probably the easiest way how to handle this is to use a Conan package, which is currently provided by the European Spallation source, a Neutron source in Sweden, respectively in Denmark. And using it is quite simple. You do this from CMake. Here's a little example how you would do this. You use find package H5CPP. We provide a CMake package file. And the only thing you have to do is here on the very bottom, just add the package to your link to your target. And that's it. And this works on pretty much all the platforms. Okay, we have a couple of users already, as of course Daisy and ESS, who basically started the entire development. We have users at the Paul Scherrer Institute in Switzerland, and we have users at ISIS. It's a neutron and muon facility in Oxford, Great Britain. Okay, the project itself. I'm too fast, that's new. The project itself, we host our code on GitHub, and we try quite hard to keep it up to date. Code is distributed under the GNU General Public the GNU Lesser General Public License, so linking would be okay for commercial applications. We try hard to keep our code clean and do quite some testing. We use a Jenkins cluster to run the tests, which is currently hosted in Denmark at the ESS Computing Center. We have currently about 92-something% code coverage. That's quite good. The red columns on the very right side here, this is branching, and this is a general problem with C++ code. This comes from code added by the compiler due to exception handling. So typically, this is a measure you can simply ignore for C++. So we have currently 3 active developers. That's Jan Kotansky at Daisy, Martin Shetty at the European Spallation source, and that's me, Eugen Wintersberger. I'm currently working for an Austrian company, a little bit off topic, but well, still try to do my job here with this HDF5 wrapper. And that's pretty much it. Thank you for your attention. And well, handing over to the next one.
Oh, sorry, I was on mute. So thank you, Eugen, for your presentation. So now we have our last presenter, Chris Green, who will be talking about tabular data in HDF5 with C++.
Hi, let's get back to the beginning. So this is a little more focused. We're aiming at a particular style of use of HDF5. So I'm going to start with a slide of motivations and origins. Where did this come from? So particle physics analysis often involves the creation of what for 40 years or more we've called n-tuples, which is essentially tabular data. Often, however, the columns are quite nested and intricate. The meaning of row is often flexible, but is consistent within a table. And we've historically relied on domain-specific tools. Some of you on the line might be familiar with an old Fortran system called POR, and the modern system based on C++ called Root. There's been a recent trend towards using more general analytical systems like R and various Python tools, and also the field as a whole is starting to move towards the HPC systems and the MPI in particular. And HDF5 would seem to be a natural choice for a flexible data format that would allow us to use the more general tools. So our scientists often mention that they really are only interested in coding algorithms. They don't want to spend a lot of time on data handling and what might be described as overhead. So from that point of view, the HDF5 C++ interface is not as flexible as we need for the things we're going to want to do with it. And the C interface, a lot of error code checking, and can seem arcane to new users. So we needed something that attempts to make the basic trivial and the complex tractable, and keep the boilerplate down as much as possible. So in order to talk about what we do and why, I've got a case study from our field. Lariat is a liquid argon experiment studying neutrinos, and it's basically a huge tank of liquid argon with wires running through it that collect charge from ionizing particles as they pass through. So you can imagine this chamber. We have two sets of 240 wires in different orientations, and we're taking 3,072 time samples per wire, and we can use the timing of the charges to build up an idea of exactly how particles were traveling through the tank. The data sample is somewhere north of 15 million events, and the data we're interested in saving here include an event identifier, the ADC sample data for the two planes, the wire number for each set of signals, and pedestal information, the mean and sigma of average readings on those wires. So n-tuple package, it's based on modern C++. So you are able to use it in if you're using C++ 11 or better. The current standard is called C++ 17. We map the concepts of table and column respectively to an HDF5 group and data set. And I have a diagram here showing how that is organized for the data for the U-plane. And we have data sets for the ADC, the channel ID, the pedestal mean and sigma, and the rows and elements are do not have direct HDF5 entity analogs here. So a column is a fixed size array of basic types or fixed or variable length strings, and the user will insert data a row at a time. When defining the table, the user will specify a name for each column, the basic element type, the dimensionality, and the extents in each dimension. So for our case study here, the U data, for example, the ADC data will be 240 by 3072. Ntupl is a C++ template where the column element type and the rank are fixed at compilation time, and the extents are specified at table construction time. Data sets from the point of view of HDF5 will have one more rank than the user specifies, and this represents the column entries for each row. So our data set of shorts for the ADC data for the U-plane will actually have will be n by 240 by 3072, where n is the number of rows we've written so far. Rows are buffered internally and written in groups, and I should point out that Ntupl is a system for writing data only. The files can be read with standard tools, and certainly H5 as we've used locally is more than up to the task of reading those files. It's exception safe, and it features resource cleanup using the RAII system in much the same way as the previous presenters have described. So moving on to the description here, simple things are, as one would hope, very simple. One defines the Ntupl. Here we're defining a very simple one with an integer scalar column and a double scalar column called A and B. And the simple .hdf5 is the file name, and this table is going to be called data. Very simple. The data to store, this is obviously a toy example. We don't care where it comes from, so this is the simplest way to explain. And then we're writing 3 rows here, one at a time, taking, in this case, 1 4.5, 2 and 5.5, and 3 and 6.5. Simple things are often not so simple under the covers, so I took the liberty of writing out the HDF5 calls that get made. You're creating the file, you're creating the group. For each data set, you're specifying the properties. If you don't specify what you want to do, the default is chunking and default compression. One has to create each data set, and then for each write operation, one can see 7 calls there for each write operation. And even as complex as this is here, I've elided all the close calls that one needs to make for correctness there. Complicated things are still fairly simple, I'd like to think. So here we're using a helper function or two, make Ntupl. One specifies the top level information here, so the file name and the table name there. And then we're specifying a two-dimensional column of unsigned shorts whose extents are 240 by 3072. And we would like to shuffle and compress the data there. And then we have a column of unsigned shorts for channel ID, a column of floats for the mean, and a column of floats for the sigma. And then reproducing much the same call with a slightly different specification for the file. So we're using the same file. We're not opening a fresh one. And then the bottom line there is an example of how one would insert the data. And this here we assume that, for instance, the first two items of data are in STL vectors, and the second two are in C-style arrays. Reading with Python is as trivial as one might hope. It's effectively one line to get the data into a NumPy array there, for example, using H5 So let's have a few more details. The template is a variadic template, so you have an arbitrary number of columns that one can specify. And we have helper functions that help you embody more flexibility as necessary while attempting to keep the syntax tractable. Tables can be inserted into an existing HDF file anywhere in the hierarchy of the file. And filters can be applied and chained, and other properties customized as one needs. Even with the, if you wish, if for instance you are writing once on a big endian system and then reading many times on a little endian system, you can specify that the data are written in little endian if that is something you wish to do, using just the standard type specification through HDF5. Data organization. The column entries are contiguous and row major or C-style arrays. And as I mentioned before, we have exception safety, resource cleanup, and that's the description of the system there. Performance notes. Buffering and chunking is configurable as one needs, and that will reduce the dataset extension operations and the churn from that. Ideally, the buffer size for each column would be an integral number of chunks. And the files produced this way, we've used them successfully to examine the full corpus of Lariat data. And over at NERSC there, we've been able to run a 1200 node job, which read and decompressed the 42 terabytes of waveform data there in somewhere south of 20 seconds. Once the individual ranks have actually started themselves up. The library is not just Entipole. There's a lot of stuff in there that supports it, that is available for the user. We have resource managing classes for the common HDF5 entities. We have the ability to add attributes to data sets and groups, metadata. We also have a file concatenation utility for the Entipole style files. And with a recent enough HDF5, one can take advantage of MPI-IO there to run the concatenation in parallel. Error handling. We have a system that allows exceptions to be thrown safely on HDF5 errors. Within the library, one can set the default behavior. So everything I do, for example, has this exception throwing feature turned on, and you can actually make your own direct HDF5 calls in this way by using a variadic wrapper function that just wraps up the HDF5 call and all its arguments that you wish to make, and then throws an exception if the answer is suboptimal, and then everything else gets wound up and cleaned up after that. Our project is on Bitbucket, and that is the URL there, and we would welcome people looking at it and telling us how it could be improved and how it might work for them. Current users are locally, and also it is extensively used with within the NOVA collaboration, which is another neutrino experiment in particle physics. And that is all I have to say.
Thank you, Chris. We have enough time for questions and answers. And let me, since for some reason the questions were not, there was no indication for whom the questions were directed, I will go through the list of the questions and will ask each presenter. And the first question, first of all, just a reminder that this recording, the recording of this seminar will be posted, and we'll send you the link. And also we'll send documents with questions and answers. The first question to all presenters, probably it was directed to Steven. Are you using Visual Studio are you Visual Studio 2017 compatible? And I think it's all presenters may answer. Steven, please.
As far as I know, it works with Windows platform. I personally do not use Visual Studio. However, has been confirmed that it works with.
Okay, thank you. Eugen.
You can build the code with Visual Studio 2017. Most probably you have to use, for the time being, the 2015 compiler toolchain, which can be integrated quite easily. And the reason is incompatibility between Boost, with the version of Boost we currently use on the Windows build. But once this is fixed, so I would have to look it up. If there is a fixed Boost version available, that would be no issue.
Thank you. And Chris, would you want to add probably?
If I may add to that answer, the other thing is that looking forward, C++ 17 has a file system becoming available and supported through C++ 2017, and that's that will eliminate the need for Boost. So in fact, things will become more compatible as the future comes to us.
Thank you. And Chris, what about your software?
Our software is built with CMake, and provided the compiler can handle the standards compliance that we require, there's no reason why not. But we are manifestly not a Windows shop, I'm afraid. So it's not something we test.
Thank you. There was a question that directed to all presenters. Are any of the projects represented here today looking at the possibility of having HDF5 I/O requests occurring from different classes of memory, for example, GPU memory?
Sorry, I do not understand the question. Maybe.
Unfortunately, the person who asked the question left the meeting, and he asked me to ask. But maybe we can send this question, and you can answer in email, and we'll publish it. And we can contact the author. Steven?
No. The current approach to this, that from GPU memory, you have to link against, if your linear algebra library supports such transfer, then this version of H5 CPP does support it. So this is a linear algebra system specific detail. If it supports, then it will work. If it doesn't support, then it requires extra coding.
Chris, if you want to add something to this.
I think I can say that as simple as our system is, the insert function there requires pointers, and where that memory comes from is somewhat up to the user. So provided it can be specified as a pointer, I don't think we care.
Okay, thank you. So the next question is for, I believe, for Eugen and Martin, because it's H5 CPP low case. Can H5 CPP handle big data, load files that are bigger than RAM?
Hang on. Why would this? So a file bigger than RAM? There is no issue. It's a file. So I don't think that's an issue.
Yeah, because you can read by hyperslabs, right?
Yeah. That was basically, if you can remember, that this was one of the big use cases we had in the entire synchrotron community, dealing with data far bigger than RAM.
The next question is for both lowercase and uppercase H5. Are you guys supporting multi-threaded reading of files?
That doesn't, as far as I know, the I/O layers of operating systems. This question is not. It requires some context. So no. No, but it doesn't answer the question. So the regular, probably the regular way to access multiple disks would be something like RAID, and through one device you would access to its storage. I don't really understand the question how that actually would be applicable.
So, from my point of view, I partly agree with Steve. This is a very difficult question to answer. If I make an assumption about the use case where you have a multi-threaded application which wants to read from a single file, independent now where this file is stored, then no, we don't provide explicit multi. So our API is not thread safe in that sense. Well, what you would consider thread safe from a textbook, the definition. It usually doesn't make too much sense to do it.
Thank you. The next question was, I believe, for based on timestamp, it was for Chris. What's your comment on partial I/O row versus column-wise? Or maybe it was Eugen. No, it was probably Chris.
Yeah.
Partial. Try that again, please.
What's your comment on partial I/O row versus column-wise? So I guess because your data is column-oriented, how you write it.
Chris,
Right.
would you like to try this?
Please, if you've got a handle on it, sure.
All right. So the library we have accepts data from the user row-wise because that is our use case, right? In a particular analysis, we see one event at a time, and so want to write out the data for that event and then move on to the next event, write out the data for the next event. So that's the user-facing part of the API has to accept the data row-wise just based on our use case. The data, when written to the HDF file underneath, are written column-wise, and our analysis use cases, our style of analysis is using a system like pandas, for example, in Python, where we operate on whole columns of data at a time. So the style of the interface is driven by our usage pattern.
Thank you. The next question is there an equivalent of H5 Repec built into the new API? And it's probably for Eugen and Chris. And I'm not sure how I interpret this question. If there are APIs to do what Repec does, but I will let presenters.
As far as I know, this is not going to happen. I don't know how. I mean, I'm not sure. Do you have an API for this in the C code?
Unfortunately, no. But as a rule of thumb, we encourage, like the best practice, to build the tools from using public interfaces. Then it can be kind of high-level interfaces, meaning they do a lot of things in one call. And it's very possible that, for example, if we look at current code of our command line tools that are written in C and compare what tool does and create the same code in using H5Py, it will be much less code to write. But there are reasons why we're doing those tools in C APIs. So using H5 CPP or another CPP APIs may facilitate creation of the tools for sure and provide some functionality. So I guess the answer is no, but people are really welcome to use those APIs to create tools like productivity that was mentioned in the first presentation. This is the key.
No, we don't have any plans in this direction for now.
Mm-hmm. Okay, thank you. And I still have time for, there is a question, under which licenses are these interfaces released? And I will start with Stephen.
MIT, very liberal. You can use the headers for whatever purpose you would like to. The compiler it does have an advertising clause inherited from LLVM project. Is in binary format. The output code is MIT licensed, and you can use it the way you would like.
Thank you. And Eugen, you had the slide, but it will be good to reiterate.
Yeah, we license, we used the LGPL. So the idea is you can link dynamically with our library, but if you add changes to the code, do modifications to the code, we would like you to share this with others.
Thank you. And Chris?
Our license is it's officially the Fermilab license, but I believe it's essentially the 3-paragraph BSD license. Would you agree with that, Marc?
Yes, it's essentially the BSD3 clause.
Okay, thank you. And the last question is, does quantum computing work with the energy saving for the time and consumption? This is for Fermilab, a question for Fermilab.
Jim, is that you?
I don't quite understand this question. Certainly, the library we're talking about here has nothing to do with quantum computing. However, Fermilab is involved with quantum computing research, and there is a Fermilab Quantum Science Initiative, and so the Fermilab website has information about that and contact points to ask questions about Fermilab's involvement in quantum computing.
Thank you. This is a question, I believe, for community to reflect on. Seems like we need a presentation from the C++ interface that is integrated into the core repo. If a different purpose, what's the purpose of the one integrated versus these third-party libraries? And I will try to start answering, but I will welcome presenters to reflect on this. Our HDF5 C++ interfaces were created first in very late 90s, I believe. They were added to the library. And at that time, we found that many compilers, we couldn't use some features, powerful features of C++ because of portability in compilers. And after that, we went into the maintenance mode for HDF5 C++ APIs. We cannot, as with long, software, HDF5 software is now more than 20 years old. As with any software, legacy software, you cannot simply remove APIs, which sometimes we do, and forum rightfully acknowledge our mistakes and keeps us responsible for what we're doing. We cannot remove those APIs because there are applications and sometimes critical applications that use those APIs. People cannot write the applications that now in production. So we are committed to continue supporting what we have, enhancing as we have time and bandwidth. We absolutely accept contributions, and if you want to contribute to HDF5 C++ API, please contact me or just send email to help@hdfgroup.org with your page or suggestion of put it on forum. We will be gladly working. As you notice, those three presentations came from different angles, and they are essentially trying to solve different problems. And all of those approaches are very valid. HDF Group is not endorsing anything, and we would like community to really find what you need and what is working for you, and use whatever is, use whatever is working, what you think is the best solution for your application. But I will ask them to reflect, Steven, on this first.
Can I have the question again, please?
Thank you, Steven.
So we have three different projects going on, and what is the relation with the HDF5, official HDF5 C++ APIs? And I would say diversity is really very good. You find what you need, what is more useful.
Luckily, I can be blamed only for one of the three projects. I'll take full responsibility. The very reason is the C++ API of the current HDF provided by HDF Group is somewhat outdated. It's based on a coding style of the early 2000s, and things changed over time. The approach that this project took is much lighter in terms of coding and linking. It only requires the C API and the math library, I believe. That's correct. So it's very lean and linguistically has features much similar to Python. That's up to date with the C++ 17 standards using template metaprogramming, and this technique is missing from the original C++ library.
Mm-hmm.
I hope I did answer the question.
Yeah. Eugen, what is your view on this? Multiple packages that do have HDF5 C++?
Well, I guess partly Steven already said the important things, that the libraries, the original C++ wrapper is basically outdated, and C++ has changed a lot over the years. It's more or less in our local C++ user group, the general notion is that consider C++11 as a new language, and of course the upcoming standards. So the one thing why we started with this project was that the original C++ wrapper did not cover the entire C API functionality. And one thing came to the other, and I already did once a wrapper, and another guy did a wrapper, so we put everything together and started over again. And yeah, with maybe a bit different approach than Stephen has taken, but I think fair enough. That's okay.
Mm-hmm. Thank you. And Chris, would you like to add to this something?
Only to say that our attempt at this is very narrowly focused to a particular use case that we needed to satisfy for our users. So we could easily re-implement our interface on top of probably either of the two other systems presented here today without great issue, but we did it to satisfy the use case we had.
Thank you. There is another question for you, Chris. Do you have any plans to add reading functionality to ntuple? The write-only approach will not work for me.
Ntuples can be represented as a POD or plain old data structure types. And this functionality is implemented seamlessly. You basically can do operations with arrays, std vectors currently, and use the compiler to get the necessary schemes or compound data type descriptors. So yes.
Thank you, Stephen. I believe it was a question for Chris too. So Chris, could you please answer? Plans to add reading? Mm-hmm.
We certainly don't have any immediate plans. If there was a feature request, then we would look at it.
Okay, thank you. And the last question was for Stephen. What is the latency of reading and writing?
That's a good question. Very low latency, but this can be controlled. So there are caching mechanisms, and it really depends on what the intermediate cache sizes are. It's definitely within the range for high frequency trading. I know the top of my head. I don't really know engineering numbers for Pareto colliders, but it can be controlled and refined to the point that would satisfy the engineering lower and upper bounds. Not sure if I answered the question.
Thank you. This is the end of the list of the questions. If you have more questions, don't hesitate to post it on the HDF5 C++ users group on forum, or to help at hdfgroup.org, and we will answer those questions. As I told, we will post the recording, we will post questions and answers. And thank you so much to our presenters, and thank you so much for joining our first webinar. We hope to see you again at other webinars. Thank you so much. Goodbye.
Bye-bye.
Bye-bye.
Thank you.